passed since Edwin Hubble's discovery. Yet today its profound implications still evoke a fundamental question. Does contemporary scientific knowledge actually confirm the Copernican principle's primary claim, that the Earth and the life it sustains exist without purpose or significance in the universe? An outgrowth of the Copernican principle is the belief that habitable planets and complex life are abundant throughout our galaxy and the rest of the cosmos. Perhaps no scientific endeavor has been influenced more deeply by this idea than the research program called SETI.
Well, SETI, which is, of course, the search for extraterrestrial intelligence, is trying to do exactly that. We're searching for extraterrestrial intelligence. In other words, we're looking for aliens that are at least as clever as we are. Now, we try and do that not by trying to go there the way they do in the movies all the time, or waiting for them to come here. We try and find the aliens, if you will, at home on the basis of eavesdropping on signals they might be sending our way. So we use large telescopes pointed at other star systems to try and find these telltale signs that there's some cosmic company out there.
Since 1960, SETI researchers have utilized radio telescopes throughout the world to monitor transmissions from distant regions of the Milky Way. While no definitive signs of intelligent life have ever been detected, these investigations have triggered much speculation about the possibility of extraterrestrial civilizations.
Estimates vary all over the place. Carl Sagan thought there might be millions of civilizations that are kind of contemporaries of ours. I can imagine that within the Milky Way galaxy, the number of contemporary intelligent civilizations, I think, is probably in the thousands, maybe hundreds of thousands. But the bottom line, actually, when people ask, well, why do you think that they're out there, is that the universe is extraordinarily rich, extraordinarily vast. The number of stars that we can see is on the order of 10,000 billion star systems. So unless there's something very, very special, miraculous, if you will, about our solar system, about our planet Earth, unless there's something extraordinarily unusual about it, then what happened here must have happened many times in the history of the universe.
The assumption that habitable planets and extraterrestrial life are abundant has inspired not only the SETI program, but also the new science of astrobiology and the search for biological evidence of living organisms, past and present. Since 1995, this search has extended beyond our solar system, as astrobiologists have identified more than 100 planets orbiting nearby stars. Each of them is a gas giant, much like Jupiter. While few scientists believe that these alien worlds can sustain even simple life, their discoveries represent important steps toward answering a question that will shape astronomy in the 21st century. Are habitable planets rare or common in the universe?
I'm an astrobiologist, and the area that I've done the most work in lately is the field of extrasolar planets. What motivates me is just to examine the conditions necessary for life and look elsewhere in the universe and see if those conditions are met anywhere else. And the answer could be yes, and the answer could be no, and either answer is interesting.
Guillermo Gonzalez works as a research scientist in NASA's astrobiology program. His interest in this field is tied to his early fascination with the prospect of life beyond the Earth.
I grew up in the 1960s, and like most other people of my generation, I was really amazed by the Apollo lunar landings, and that really inspired me and had something to do with my getting interested in astronomy. In my early years, I came to believe very strongly that there must be other civilizations out there and that the galaxy was teeming with life. And so I was a strong supporter of the search for extraterrestrial intelligence. My belief wasn't based on any real hardcore scientific arguments. It was just the impression that I had that the galaxy was such a big place. And I didn't give the other side of the equation much thought. In other words, there's two sides of the equation. There's the number of stars, the number of trials, if you will. But the other side is the factors. It takes a lot of factors to have a habitable planet and a planetary system.
For Gonzalez and other astrobiologists, these factors, required for the Earth's habitability, became the focus of extensive research.
We've demonstrated in dozens of different ways the laws of physics and chemistry that pertain in a laboratory anywhere on Earth apply anywhere in the solar system, apply anywhere in the galaxy, and in many cases out to the most distant galaxies that we can see.
There are indeed unchanging physical laws in the universe that apply to the entirety of the universe, that they're not localized to one place.
This consistency in the laws of physics and chemistry has led many researchers to conclude that the factors necessary for complex life on Earth are also the best parameters in the search for habitable planets elsewhere in the universe. Most serious discussions about these factors begin with the same prerequisite: liquid water.
All the searches that are being done for life elsewhere, their starting position is a terrestrial class planet with water.
It is now widely recognized that the chemical properties of water are exquisitely suited for carbon-based life. These properties include water's ability to dissolve and transport the chemical nutrients vital to all living organisms, and its unmatched capacity to absorb heat from the sun, a process critical for regulating the Earth's surface temperature. In liquid form, water is an extraordinary substance, and its existence hinges upon another factor essential to complex life: a planet's distance from its home star.
It's like what they say in real estate: location, location, location. A habitable planet lives in what we call the Goldilocks zone. It's not too hot, it's not too cold, it's just right. And when I say just right, I mean just right for water.
Liquid water really helps define the habitable zone. If it's too hot, again, the water just boils away. You just can't get condensed water. It's too cold, as in Mars today, it freezes out.
Within our solar system, the habitable zone is relatively narrow, beginning well outside the orbit of Venus and ending short of the orbit of Mars. If the Earth were just 5% closer to the Sun, it would be subject to the same fate as Venus: a runaway greenhouse effect with temperatures rising to nearly 900 degrees Fahrenheit. Conversely, if the Earth were 20% farther from its home star, carbon dioxide clouds would form in its upper atmosphere, initiating the cycle of ice and cold that has sterilized Mars.
The presence of liquid water is a necessary condition for life, but it's not a sufficient condition. After all, there may be liquid water under the frozen surfaces of Mars and Jupiter's moon Europa, but there's very little chance that complex life exists